just start recording. Okay. Okay, why am I not? Do I need to just do the scooty over thing?
No, no need for that. Where's our remote? Can you see the remote?
No,
Oh,
I
yeah,
just need to scoot. Okay, that should.
Oscar.
Rock and roll. Thank you for your patience. I can make a dozen excuses why we were late. One of them being my toddler, the other being we slept in, the other being I was late to order the tacos. But regardless, we're here, and we're thankful for your time this morning. I have a little bit of a review over what we went over last time, and then some more stuff for you guys. I brought the master, pun intended, for him to be able to answer questions and talk about all of the technical fabulous things of the electrical space. But since he hasn't met several of you, could we go around and just share your name and what you do for the company?
Yeah, I'll start. I'm Brandon, I'm the mitigation manager. I handle all the water, fire, and mold damage, and I also help out with the reconstruction.
I'm Luis, we met once, but I'm a water tech. My name is Oscar, I'm the lead technician. My favorite color is blue, so that's good.
I'm Brian, I'm a water tech, and I also kind of lead up the HVAC cleaning as well.
I'm Clay. I do P&I and project managing, and love these tacos.
Michaela, operations manager. You know James. I'm Jesse. Oh gosh, what do I do? New business development, administrative. I feel like I'm like the leader of a circus sometimes. Would you like to introduce yourself?
I'm Gabe, I'm the master electrician, so I do all of the hard stuff and then she tells me where to go.
Pretty much. Pretty much. Rock and roll. This was from last time. This is all from last time. Do you want to give a little overview of
Yeah, why this is bad?
why this is bad?
Yeah, so all of the frayed fibers there, especially when they're right next to a stud, can start the stud on fire. And it'll start to smolder at first, but it's not usually enough for a smoke detector to pick up until like it's a full-fledged fire. Because most smoke detectors don't go off, they just go off of visibility. And so without that, like, it's not gonna produce enough smoke to really do anything until there's a full-blown fire, and it's usually in the wall or in your attic, but no, it takes your smoke detector's not gonna see it, which is what makes these really dangerous. And then the open air places like that, so especially the middle picture with the yellow wire, where they have that gets really dangerous because in the event that it sparks, all of the boxes are designed to be at least 1 hour fire rated. If it doesn't have a box that spark can catch the wood on fire. And that's what starts the whole house fires. I think it's like 70% of all house fires are due to electrical. And
You say box, is that like, kind of like that silver one of the big?
Yeah.
Yep.
So,
Yeah, so it should be in a box like that with the
So like
So the box on the wall, like under the TV, I think that one, they're gonna be 1 hour fire rated minimum. I think the metal ones are 2 hour fire rated. I don't know 100%, but they're fire rated and encased properly. If it's not in a box like that, that's where it catches it on fire. And then most of the time, they aren't just clear, they're buried under insulation, right? And so you've got 60-year-old insulation that's full of dust and rat poop and everything else like that. And that just immediately goes up. So it shoots off one part and goes. And that's what makes it happen. I've seen it melt entire boxes in the wall and like up the wire several feet. So it gets really scary. And that was inside the box. So if it wasn't in a box, like that whole house would burn out. Because the box ain't alive.
last time Clay shared pictures of your house that almost burned down.
Like that.
Yeah.
John thinking like maybe it's next to his stud or something.
Most of the time it is.
what is it that causes that when it's like by its
So basically, anytime there's a big load, because most of the time if somebody's doing this, it's because they aren't an actual electrician. And so, if they're doing some sort of hackery, maybe they don't know how to make a proper screen. When it's just wired together without the connection. And so when there's that little space, it arcs, and like, that's what sends the fire, you know, like, kind of like when you go to like light a lighter, right, it's left spark. It's the same thing on all. So you're bringing two wires together, it'll arc between it, making a little spark on that, and that's what shoots off and can cause it to jump to any flammable thing here. Because really its goal is just to get back to source. So also if you just have that hot wire touching this stuff, it's trying to get back to source. Wood's not a good conductor, but if that's basically all together to the panel, it's gonna take whatever path it can to get back there. If you've ever seen like the wood burning videos where they put one on one side, one on the other, and they like chase it across, it'll try to do that in your house. Just, you're not doing it on purpose. It doesn't care. It's gonna find some path to get back there.
Broken wires, opener joints equal bad. These are all still pictures from, what we talked about
This
last
is all
time.
previous, so if you see a plug like what's in the top left corner there, where they've got multiple power strips coming off of it, it's usually a really good sign that we need to add another outlet in next to it. Because the outlet on the face of that is only rated to about 15 amps. And if you do all of that, each one of those cords can be rated to about 5 or 6. And so you have 8 of them in there, it's gonna overload that, and causes that device to burn out. So we wanna add another one in. Most of the time it's not enough to trip the breaker, it's just enough to make the device go bad. And then the picture.
The appliance or whatever is plugged in?
Yeah. So basically, we don't wanna have power strips as like a fixed thing. It's something that you use temporarily, add a little bit extra power and then move on. If you're gonna need extra spaces like that, what I would do on that one is like cut in the 3-gang box and put 3 outlets next to each other, so they have space for people. But
Because that single device is not meant to handle all of that capacity.
yeah, so the circuit's fine, to handle all the wiring behind it is great for it, it's just the actual device itself is not. And then we see it a lot on the picture just right of that, where the outlets are broken. It's usually a really good sign that on the back side, that outlet's gonna fall apart the moment you take the cover off. And like, I've had it like fall apart. Which is super sketchy. Especially when you're going to test power, and then you take it off, whole
And
thing
it
falls
like
apart.
disintegrates in your hand.
And like, the hot portion's just like floating in there next to the ground. It's really sketchy.
Is that from like heat, like that's causing those to crack like that? Or
Yeah,
is
also
that-
just age. My guess is that one is probably original to like 1970. So the electrical system's designed to last about 25 years. That one's been around for 50 years. It's just went bad. And then all of the panels on the bottom, the phones we know there, are all what we call the legacy panels. So the 2 middle ones are FPV. You tell it's the only one on the market that has like a black breaker with a red handle. Anytime you see that, it needs to be replaced. It was easily the biggest fire hazard of the electrical industry. And they coupled that together with aluminum wiring, so those houses don't exist anymore. It's just, these breakers would, basically the breakers were built during World War II, and instead of using like good silver or like consistent metal, they used spring steel, like what you can put on the bottom of your truck, which has a really inconsistent thermal level. How a breaker trips is it'll overheat, and then that can cause this, and the overload on it is just because it got too hot and it tripped the breaker. These never got too hot, and so a 20 amp breaker would hold at 45, 50 amps before it actually tripped. And so you got, if it did, and so you have 12 gauge wire on this that's expecting to not pull more than 20 amps, and you've got 45 to 50 amps on it, and so it just burns the whole thing up. Usually starting out the device and just smoldering. We had one of these when we first moved into our house.
In 2022, so
Yeah.
they're still very
prevalent.
prominent in our area.
Especially in like the older communities of Georgetown and Austin. But, Yeah, they're really sketchy. We actually have one on our house. I had a vacuum plugged into one, that's pulling about 10 amps, and then a floor grinder that was pulling like 8 amps or 12 amps, 12.5 amps, something like that. Right about 26 amps on one outlet. And
Which should have had how many?
Oh, it should have tripped to 20. Like, it should not have been able to run, and it ran for like 20 minutes. It didn't care. So like, super safe. But if anytime you see those, it's bad. Same thing with Zipstone and Sylvania. What makes those really sketchy is you can shut the breaker off and it'll still produce power because the internals of it didn't actually shut off properly. And so you can turn the breaker off, but you'll still have 120 volts coming at you. And so there's no way to actually disconnect it, like disconnecting a wire from the breaker, which you then have to be hot. So both of those again really sketchy. And then even if the breaker does trip, it doesn't actually shut power off. So all of those legacy panels is just something that the moment we see it, we tear it out. We don't even work behind them because I'm not risking my life over you not wanting to take this out of your house. Also, most insurance companies either won't insure it or will be like 3 times the cost to insure your house. Yeah.
Because
There's 4 of those.
1,000%.
I say because they don't trip breakers. Like you can take hot to ground and just hit it like 3 or 4 times before it trips breaker.
Oh, well, when you replace a breaker, do you have to replace like all the wiring throughout the house, or can you
No,
just?
you can just replace the whole panel. So it's kind of like, yeah, kind of like replacing your oil, right? So like, when you replace your oil, you don't have to replace the whole motor, right? Or same thing with your spark plugs, right? You don't have to replace the whole engine.
How old is the old for wires though?
So, anything before about 1940, you're probably good as long as it has 3 wires. 1940, because it was copper, and like copper doesn't break. It's not going to go bad. Everything's good. Now, the thing you
As
want to
long
check
as-
for is that they have proper sizing for wire, proper size ground, stuff like that. Which most of those at the time did not, because they didn't really care what grounding was. Like, they didn't even intend grounding until like 1940, is when we added super ground, because munitions stations were blowing up in World War II because of lightning strikes, and they're like, why does this keep happening? And somebody like connected to the rebar and the concrete and drove around the ground, and then it stopped.
It's probably a really good transition for us to go into grounding.
But these are like
Is
code
that on the
updates.
picture? That-
So the first thing we want to look for is grounding and bonding.
It was not doing the thing.
But yeah, I say really we just want to make sure that we have the 3 wires, that we expect the grounders are hot and are all sized properly. This is what we want to look for at any service. So at this point,
Start a little more broad. What is grounding?
so grounding is like exactly what it sounds like. It's not complicated, but a lot of people get it messed up. So grounding is the act of taking electricity to ground. It's not there to trip the breakers, it's there to protect you. It saves a ridiculous number of lives, because without it, you can get shocked in your shower, you can get shocked while washing your dishes, you can get shocked because you're walking on the concrete floor, anything else like that. Grounding is super important because it dissipates any like stray electricity. But it doesn't trip breakers, which is a very common thing in the industry. Everybody's like, oh no, ground rock trip breakers. It has nothing to do with it. And I can get into a very complicated theory on that, but I don't think that's worried about that. So, basically, we want 2 ground rods outside of any panel. Code requires 1, but basically what code says is if we don't get the lack of resistance on it, we want less than 10 ohms of resistance from the panel to the ground rod. We don't have that on the first one. We drive a second ground rod, and we still don't have it, and we say screw it, everything will be just fine because you can add 300 ground rods and you're not going to. So basically, I just drive 2, and then I know that I'm good to meet code. But it's an 8-foot long copper clad piece of steel. So it's the steel bar they wrap copper around to make sure that it's conductive. But we drive that fully 8 feet into the ground, and then we connect a 6-gauge wire to it. So the farthest one to the right there, that's most likely the ground rod that the internet company ran, just to have some level of grounding for them, because that would not be enough for any panel that I would ever install. the wire gauge isn't big enough, the ground rod isn't big enough, none of that. So, my guess is that one was just we use with your like internet because they're really sensitive electronics, and so if they don't have good grounding, it'll be wrong to the internet.
I have a question. When you say up to code, does that mean the new homes getting built, like the communities, are they coming with ground rods in the ground?
Yeah, so they'll below panel. Yeah, so normally they'll have it before they're the software. They're the sodded.
Yeah.
And so the first one will usually be right under the panel, and then the next one's over about 6 feet. But they have to be 6 feet apart or it causes electrolysis. So in the event that those get power on them, which doesn't happen often, but if it does, if you have them closer than 6 feet, basically the magnetic field around it creates a new magnetic field and then it'll backbeat. And we call it electrolysis, but basically that'll be what sends holes through your plumbing pipes and stuff like that. Because the electricity now just stays existing on the system versus being separated. So we want them more than 6 feet apart where it causes problems. But that's grounding, it's just physically taking electricity to Earth. Everywhere except America it's called earthing, which in my opinion makes a lot more sense. But America likes
The electrolysis, does that only affect like metal pipes?
Yeah, so it's not going to affect pets in any way, shape, or form because it's not metallic. So in homes plumbed entirely with PEX, with all the plastic fittings, we don't even have to bond to the gas line because there's absolutely no way that we get electricity on it.
That's probably why they went to PEX, but then they had issues with PEX, right? Or they probably did that trying to get away from.
Yeah.
This is a video of Gabe talking about how we quote an EV charger, but we reference the ground rods here.
Can't hear him.
Yeah, oh, there we go.
Making sure that that's always in tight. Make sure none of these wires pull out because they do sometimes. Embarrassing to the electrician. Obviously this breaker is shut off. I'm not sure exactly why this is a new build, so I'm not gonna touch it. But yeah, everything's looking good there. They've got ground rods coming down. I can see it based on the house on the other side. And over there. So their own ground rod. That's the same thing we have right here. So that ground rod probably sits right around here. See, it's all rusted.
Little bitty ground rod. So that goes 8 feet into the ground.
Now we can go load calculation.
But that's where ground rods come into play. Those are required on all new services. They used to let us just do a U for ground, which is where we tie into the rebar and the concrete, and they let that be good for years. But it's an unverifiable ground, is what we call it. So there's no way to verify after construction, even after the concrete's in, whether that ground is actually doing what it's supposed to. Right? Because we put it in, like as they put the rebar in, then they put concrete on, then they put studs, and so like the chance that somebody broke that wire is pretty high. And it's just like in the concrete, broken in 2 pieces, not doing its job.
Can you talk about the job that you quoted yesterday?
Yeah, so yesterday we went out to a call from Mitchell over at Airstrike. The HVAC system had a burned up wire, and we're assuming it's from big surge. But I got out there. The guy has a brand new panel, doesn't have surge protection, didn't have ground rods. I really think that they just called somebody and they came out and pulled the meter and did it, and then put it back and called Encore, which you can do with Encore, but you have to get it permitted, and I don't think they did. So we got them ground rods and then surge protection appropriately to make sure that it's protected correctly. So this is the surge protector that we use, but
You're good now.
okay. But yeah, ground rods are super important. If you don't have them, it's sketchy.
Bonding and then your
Yeah,
structure.
so this is the other part of grounding. A lot of inspectors will call this grounding. This is not grounding, this is bonding. So the only part that grounding happens is when we bring it to Earth. After that, anything else is bonding. So we wanna make sure that the entire system is, has an equal potential ground is the verbiage that we use. But basically we wanna make sure that everything's equal electrically for all metal services inside of the house, whether that's commercial or residential. And so commercially, we bond the building steel, but here, we bond the gas line, we bond the water line, and then that bonds everything else. And then like on outlets and switches, you have the little ground screw. That's a bonding screw. We just call it the ground screw because I don't know, people don't know the difference.
So
So that makes sure that you don't get shocked in your shower, you don't blow up your gas pipe in the event of a lightning strike. You don't get shocked when you're cooking dinner, all of that fun stuff. Like that's what prevents a lot of those shocks and electrocutions and like really bad stuff happening, especially like showering. If you don't have the water line bonded, the concrete is, or it should be. And so you're showering, your water has electricity on it, but your concrete doesn't. And the concrete will conduct electricity to the tile and you'll get shocked through that. So it gets really dangerous if you don't have that appropriate.
So we ended up doing a course for some home inspectors who are well versed in electrical code, but grounding and bonding is kind of this foreign concept that a lot of people can't really flash their brain around. Correct me if I'm wrong, but in simple terms, the ground wire or the ground rod is an opportunity to get the electricity, the excess electricity into the ground. Bonding is making the connections from whatever electrical device to the ground rod.
Yes. I mean, it's more getting it to the grounding system.
To the grounding system.
You'll have two hots and a neutral on any residential service. And so we have all of the grounds and neutrals bonded at the main panel and then nowhere else. And so the ground rod comes off of the main panel to just get a center tap ground, which allows the system to have good voltage and everything else like that. But
without
bonding brings it back to there.
without bonding, you have a ground system that's not functioning. Like it exists there, but you haven't connected
Yeah,
A
you
to
don't
B.
connect anything to it, so it's not doing anything.
Questions on that? Is that
Yeah, I
kind
got
of
a
making
silly
sense?
one, maybe. Like, I can't think of like a specific situation, but like I've been in houses like it hasn't happened in so long, but I've been in houses where you touch something to like the shock. Is that something that anything related to?
Yeah. So if you're getting shocked on a metal surface like that, it's because the grounding isn't proper.
Really?
And so for the bonding, especially if it's an older home, a lot of them wouldn't connect the grounding or the bonding properly. And so like in the device, they'd be like, we don't need that, and then they just wouldn't connect it. Because there's a lot of old hands that were an electrician before grounding became a thing, and they're like, people survived for years without that, which is horribly incorrect because every code in the code book is a blood code, which means either there was enough people who got like seriously injured, like second, third degree burns in the hospital for several days, or died to make the code book change. It is not a light thing with like, let's just boost some
Add it
economics
in
real
for shits
quick.
and giggles.
Let's just make them have this $90 breaker for no reason. Like, no, it happened because enough people died or enough property was damaged that they went, we should probably find a way to protect this.
Well, and
So that's why the grounding became a thing, because there's enough people getting shocked while doing their laundry and dishes and all of the other things and dying because of it that they added that in.
well,
So like they could be shocked, just like the like I'm thinking of like in older homes. I know when I go to Iowa, I think my grandfather's house before he moved, like doors would just little tickles, not.
Yep.
But
Yeah,
people
so-
say you go ultimately get enough shock through a door that could.
Yeah, so you
do
can
more than a
potentially-
tickle.
Yeah, you can potentially do that, especially in the shower. I've seen it where like there's a full 120 volts coming out of the water to the ground. And so that probably like the Uber ground wasn't good, so the ground system wasn't great, but it was backfeeding to the concrete, and so you get a shock going to the door handle, concrete up. Would be my guess.
one thing I do want to note, like what Gabe is doing here is just a generic inspection of the electrical panel, just making sure that it has enough amperage, making sure that we were estimating to add an EV charger here. So just making sure that the system is able to handle that. And if you look over here, all of these are comments from other electricians saying, you don't need to do that, just eyeball it. So the amount of variance in integrity of your electrical contractor is absurd. And just because you have a licensed and insured electrician does not mean they know what they're doing. And and code, electrical code, like Dave had said, was designed because too many people died.
Yeah, it wasn't even like one person died, it was like 10 or 15 people died.
And I don't, you could probably speak better on this, but the amount of electricians who say, oh, well, yeah, that's code, but it doesn't really matter, and then do it a different way.
Yeah.
So.
Yeah, and I'm not saying that there aren't some codes.
I know I'm reading all those comments. The comments, right?
The comments are fun. Never check the feeders or heating or.
Oh yeah, we
And
have.
some of them like were satirical, but a lot of them were like dead serious. Where I was like, no, you have to do a load calculation, and they were arguing with me like, no, dude, you don't. Like that's stupid. You don't need to do that. Just like it's 200 amps, you're good. And I was like, that's not true in any way, shape, or form.
Some of those are bots.
It's been really fun.
Those are the people who everybody's commenting.
Yeah, but I went like looked at their profile, and like it's a real person.
Yeah.
And they're just dumb. So surge protection is the other really important part of the new code update. This is not going to protect people in any way, shape, or form. This does not save lives. What it does is save you a lot of money. Because electronics are very, very expensive nowadays, and so all of your appliances, HVAC, ovens, washers, dryers, fridges, Xboxes, TVs, work from home stations, all of that stuff, very, very expensive. And then with the rise in EVs, like super important to have this. So the one that we have, which is an SFP unit, and you can, that's your employer, you have but it's really, really awesome. It's the only one on the market where we can take it so the cover comes on the side like that, and we can actually turn the cover to match whatever orientation we have in the panel. This has a lifetime warranty and a $100,000 guarantee on it from the manufacturer. But it's required for any big lightning strikes, power surges from the utility company, and more importantly, the transient voltage inside of your house. So, I don't know how many of you have been like in older homes where the AC kicks on, all the lights dim down really bad, and then it stops running and the lights come back on. That's a transient surge coming through. So it sucks more power to the HVAC, so the lights take half the power. So we want to have surge protection in there to avoid that. So we don't have that because we now have surge protection on all the panels in our house. And then basically what I recommend to pretty much all of my clients is one to the main panel, one to the sub panel, and then at each one of the 240 volt disconnects. So electric water heaters, electric furnaces, the condenser outside, any of that, which is what this one's for.
So that basically like distributes it more evenly.
Yeah, so basically what it does is it evens out that surge. Because basically what happens when there is a surge that comes through is that surge spikes and then dips. And so the spike is what sends the electricity, the dip is what you see the light bulb dipping. And so what this does is instead of the spike and the dip, it evens it out. It just catches the spike and then brings it to ground, which is why we have ground wire, which is why we want really big ground rods to get the ground system to correct that and then feed it even. And so when we
Can you talk through when surge protection was added and what level meets code
so
versus
So when I talk to homeowners about surge protection, about 80% of the time they think little strip molds like that, exactly what you have today on the desk there is what counts. They're like, I'm good, right? And that's kind of like having a toddler screwdriver and trying to build a house. Like technically you could probably do it. I just wouldn't. The next one is this base level surge protection. That's what you're gonna see a lot of the time on new builds. It's just a little breaker surge, and it comes in all different brands. This is just for an EPR panel, but it's where Siemens, GE, they all have their own brand. That price is like $10 and is worth about that much to protect against surges. Like it meets code because basically surge protection came into effect in 2020, but there was no code about the minimum level of surge protection.
They said,
So,
you need to have
They
it,
need to have it.
and that was all they said. So,
And
of
they
course,
expect
every
it.
contractor said, well, if we need to have it, let's get the cheapest one,
Yeah.
stick it in, and then we'll pass inspection, call it a day, but that doesn't actually protect the level of electronics that people have in their homes these days.
Yeah, and so when they first started, those little surge protectors were rated at about 3 kVA, which is the same as that power strip. And so you're expecting that power strip to protect your AC, and it's not from anything substantial. It'll take care of it.
I see that it says, there's a replace, how do you know when to replace it? Like, what would make you go bad, I guess, is what my question is.
It's a big surge. So if there's a really big surge that comes through, it'll go bad, and that pipe will turn razor red. Then you'll know that it needs to be replaced. These both have a lifetime warranty on it in a residential setting. So in the event that that happens, it's really easy to install.
Okay, so you go to buy a home, right? Because Charlie and I are looking to buy a house this next year, and you get your home inspection done or whatever. Are they checking for all of this stuff, or is it better to like pay somebody like you, hey, can you come out and like look at this, because you're gonna buy a home and I'm gonna need $10,000 in electrician work done, and I wanna know about that before I buy the home, so I can use that as a bargaining chip and hopefully get, you know, at least some of it paid for.
Yeah, so I would have MEPs of mechanical, electrical, plumbing come out and do an inspection of it. The home inspector is gonna do an okay job. They also don't know, it's just, it's like, I'm gonna essentially have an X-ray vision that's walking through your house and being like, okay, this is a problem. Like, he's never gonna see it, but I know that's a problem because I've wired it in.
Yeah.
I've corrected this now. So my recommendation for all these home buyers is to bring out 3 main, like mechanical, electrical, plumbing, like give the general home inspection, because they're gonna check the siding, they're gonna check and make sure that like the roof is good and all of that. But bring out the 3 licensed guys there who have really good knowledge on that, or gonna be able to tell like this is gonna go bad in the next 6 months. He's never gonna know that.
Yeah.
So I recommend doing that because they're also not gonna check for like, do you have an adequate level of surge protection? They're gonna see that little break in there and go, yep, checks the box, you're good to go. And it doesn't do anything. Like, it's now required to be 10 kVA. The most lightning strikes and utility power surges are at about 90 to 110,000. Full amps at 90 to about 110 kVA, which is a massive amount, and that's what blows up your electronics and fries everything. The surge protection that we have here has a 200 amp or 200 kVA. That's well over what we need for that, which is why they do a lifetime warranty on it. I've been installing them for 5 years, and they never had replacement. So like they're phenomenal units and absolutely bulletproof, especially if you have an main panel, sub panel, all of the 240 volt loads and things like that.
Know how often they can take switches?
No. So what makes these so incredibly awesome is inside of it, at least the bigger unit, I don't know what the smaller unit is, that's more of a supplemental anyway, but the big unit, the Series R, is the only one on the market that can take a surge every, I think it's every millisecond. Otherwise there were like 2 milliseconds, but I think it's every millisecond, and do that forever. Because it has 3 different, little capacitor surge protectors in it, and then a thermal overload. So most other brands have 2 of them, they don't have the dissipation thermal overload. And so if they take one, they take the next one back to back, and then the 3rd, 4th, and 5th one get through, well, these 2 are cooling down, and then it's ready to go again, probably half a second later. But if you have several back to back, that 3rd, 4th, 5th one is gonna blow up your electronics. These have 3 of them and a thermal overload, so it actually actively dissipates the heat from all of them, and so it's just running a cycle continuously, which is phenomenal.
So oftentimes, when we go out and we give estimates to clients, the largest complaint that we get is our price point. And we're working on our messaging to our clientele that we're not your standard electrician, that we're providing you truly exceptional products and services to protect your home. And with that comes a higher price point. And so
About 80% of the products that we use have a lifetime warranty on them. Like through the manufacturer, and so we honor that with a lifetime paper warranty. Because if I installed it and I stood behind it, I don't see any reason why I shouldn't do that. Also, if I did my job right, it's gonna last for 25 years. Most people aren't in their home that long, and if they are, in 25 years, I'm happy to come out and get that taken care of. But if you design the system properly, it's not gonna have any big issues. So, that I wanna talk about is grade risers. So we see a lot of these, especially on the older homes, and they're not even legal anymore, like you can't legally put these in Austin, like in the greater Austin area. It's still rated per code. There are some areas in the US that still allow this. I think that is crazy, but they still allow it. And so what this is it's just basically really heavy duty Romex that you have inside of your house. It's rated for outside, but as it deteriorates, you can see where that one's falling off the wall because a storm came through and tore it off the wall. This one, third picture to the left, like it's underneath the eave of the house. So in the event that anything happens, like all of the lines going to that are from the utility company. So in the event something happens, like there's no breaker to shut off. And the transformer's not gonna trip. In the event that it sees any sort of like interference, where like residentially or commercially, like it'll trip the breaker and then an electrician comes out to figure it out. The utility company just sends another 25,000 volts to see the line. Like that's how they deal with problems. They just send more power, it blows it off the line like this big. That is their solution to problems. It's just blow it up.
Those are only on the fascia always, or, cause I've done roof replacements.
Yeah, where they're
On
like,
older homes where but the power comes off the top.
yes.
But we normally use like a split boot, so we don't have to catch it.
Yep, and that's what I would do, that's what they should have. So this PVC is here, that one ripped out, that's an underground service, so yeah, that's another thing that we're looking for. Is if you can see those wires from the utility company, again, those are 100% hot, 100% of the time, it will melt that meter can before it shuts off, I promise. So, we wanna make sure that we get that corrected, there's a little split coupling that we use, so that as the earth shifts, it moves with it. If they don't have that, that's what happens. And then it gets really sketchy, and like, the kid can go stick up there and touch live wires that do not have an outlet. So it gets really dangerous really fast. But the middle picture with the really braid wires, I see that a lot. And again, really sketchy because it should have that like gray jacket around it, even weatherproof. It no longer does.
So if you touch that, you're like burning up.
Yeah, there's a chance you're gonna get shocked pretty bad. And again, there's no off switch. So that's what makes these so dangerous. And what we're required now is that like 2-inch metal conduit that goes up through the roof. And so that's where you have the split boot. That's what is required now to where it's protected. And that 2-inch rigid, like you can hit it with whatever you want, you're not gonna break it, right? Guarantee it. It's what I use to sleeve under sidewalks because I just hit it with a sledgehammer until it goes under the sidewalk. And then it's all good. So that's what we're required. We do that with THHN and it's done properly after that. The next big thing is AFCI and GFCI protection, especially AFCI. Most of the time we have GFCI notifications when they're supposed to on the web locations. AFCI is still a relatively new code. It's not horribly new. Came out in like 2002, but when it did, it was only for bedrooms. At this point, we're required to have it for all living areas. So anything outside of the bathroom and the garage. Why they don't require bathrooms? No idea, but they're not required. I think it's because hair dryers kept tripping it constantly, personally. But it's not required in bathrooms. It's not required on the exterior of the house, but everywhere else inside of the home should have an AFCI breaker. And what that does is looks for any nick in the wire, loose connection, any like switch going bad, stuff like that.
So like
Yeah, like what we saw at the beginning.
all of that.
Yeah.
AFCI looks for that.
Looks for that, and if it sees it, it'll trip the breaker, and then I get the super fun job of spending about 3 hours troubleshooting. Yeah. Oh, and arcs are intermittent, so the AFCI will see it, and like a lot of the problems in electrical I can use with my meter and test it. For arcs, the only way to find it is with electricity on it. So I have to go and split the circuit apart in the middle, turn the breaker back on, see if it tripped. If it did, then the arc's on that half. If it didn't, the arc's on that half. And now I get to go through and just keep connecting until I find a wire that's bad. Not fun at all. I absolutely hate it. Like, I really genuinely do. I still believe in arc faults because if it's tripping like that, it's doing its job. What a lot of electricians will do, especially the older ones, is they'll take out the arc fault and put in a regular breaker. when it's tripping like that. And they're like, no, it doesn't trip. You're good to go. And like they just
But that
created.
wire still looks like that in your wall.
Yeah, or there's a loose device or something else like that. But like, there's a problem, and they're usually not that dramatically bad. Normally, it's going to be like the neutral and the ground hit, or they turn too tight around a stud. About half the time, it's a light bulb, which let me tell you, people get really pissed off when you charge them like $600 to change a light bulb. But I can understand. And so, yeah, a lot of the times it'll be a light bulb or something like that. But the loose connections, the bad breaker, or the bad devices, stuff like that, like it happens a lot. About a third of the time, we just end up replacing the breaker with another arc bolt, and everything's good. It's just nuisance tripping because the technology is still fairly new. But it's a lot of safety built into that one device. This is also an electronic breaker, so it actually has a little computer in it, which is another really big reason to have surge protection on these, because as those surges come through, it damages that computer, which is what causes that nuisance tripping. So when I go through and put in surge protection with AFCI, I don't have the issue. So a lot of the other electricians do, because I'm legitimately protecting the electronics in the breaker.
I think something to note here, you know, I would say the general populace is familiar with GFCI and that it protects you from shock, and that you should have GFCI receptacles, especially by wet locations. AFCI is a newer concept, and I find oftentimes people say, well, I have a GFCI, so I'm protected. But they do completely different things. The GFCI is protecting you from getting shocked. The AFCI is looking for those nicks in the wire and protecting your home.
Yeah. So AFCI is for your property, GFCI is for you. And a lot of the times, like if they think that they're good at GFCI, it's kind of like having brakes and then not wearing your seatbelt. Because like the brakes stop the car. But if you do it correctly, it's going to make sure you don't hit things. But if you have brakes and you don't wear your seatbelt and you slam on them, you're still going to hit your head off on the dash. Like it just so it's two different levels of protection. It's just still new, and there's a lot of really bad blood in the electrical community around AFCI because it creates another problem that we have to troubleshoot. So now instead of me going out and finding where somebody nicked the wire and touched the ground to the hot or the neutral to the hot, I now have to go and figure out where somebody touched the neutral and the ground together, because that'll cause the AFCI trip. Because it looks for any of the wires touching, where a traditional breaker only looks for the hot to touch the ground or the neutral. So it just adds another level of problems that I have to solve, and a lot of electricians aren't willing to do it, which is aggravating.
That's our last page. Did you have anything else that you felt like was important?
No, those for this one. I mean, there's a lot of things, and I could preach for hours on end about.
I got one more question. I noticed on like the other breakers, one was an exterior breaker, but on the other photos later, like these are all black. The ones in the beginning, there's like red and blue and
So for this one here.
yeah. So those are two different breakers, right?
Yeah,
Those
so
are
there's two different panels. So these are legacy panels, FPE, Cisco, Sylvania.
Good rule of thumb is if you see colors like that, it's not, it's
There's
bad.
not color
Yeah,
anymore.
really, I would say on the handles there's no colors. Where
Go
you'll
back
see
to,
where you'll see the colors is on the sticker there. So the blue or a button will be colorful. So GE has a purple, white, and green, I will say. But like those, like the button can be colorful. If the handle's colorful, then yeah. The only one that isn't a solid black like that is EECH. It's a brown handle. Those are great handles. I absolutely love them. Like that's what we use because it has a lifetime working on it. But
like, you can't really see the panel.
yeah.
Right, like all those are black.
Yeah. And so that's a brand new span panel that we installed, which is a whole nother cool piece of technology that we'll sell eventually again.
Nice cable management there.
How much does it cost on average to put an EV charger?
Uh,
I mean, I get, if you have to replace panels, right? Like, assuming your panel can handle it, you don't need a whole new panel.
Usually it's about $2,500,
Oh, that's
which isn't terrible. Assuming single story, every so often we're gonna do a 2-story, and the panel's on this side, the garage on this side, and we have to go all the way up and over, and then it's like $5,000 or $6,000.
Yeah.
But assuming that
But starting at
it's
about
pretty close,
2,500.
yeah. It's usually about $2,500 for just the EV charging circuit. If we want to do surge protection and all of that, it could be about $5,000 for the whole.
Charlie wants to get an EV once we buy a house.
I mean, honestly, like I've heard amazing things about them, where like you no longer have to worry if like, did I fill up with gas yesterday? Or like you have a long day and it turns to like the gas light comes on, but you're a mile from home and you're like, I just thought. And then you get in the car in the morning and you're like,
Ah, crap, I forgot.
well, I'm gonna be late to that meeting.
I have never done that. Me never.
Yeah, and so with EVs, it's always full in
Yeah.
the morning, which makes it really nice. And then, depending on which one you get, like they have credits towards charging and all of that too.
Yeah.
And depending on where you live, so like with Jesse and I, the power company that we go through with Encore, especially if you live in Hutto or Round Rock, you get to pick your provider. You can find some that are like 3 nights, and so you just charge your car at night and you'll get the charging. And,
Hey. I don't think I have that currently, but I don't know where to buy it.
Do you usually see a spike in your electric bill once you get an EV charger or not?
yeah, but it's not crazy. Like it's not gonna make it go from $100 to $900. Most of the time it'll have about $120. But considering that you get to offset the gas that you're spending, like if you're filling up 3 times a week or 3 times a month at $30 to $80, depending on what vehicle you have, it well offsets it.
Well, I think they were. I don't know if they still are. You were able to get like tax discounts and
Yeah.
stuff at the end of your EV file for because they like are promoting EVs.
Yep.
California was pushing it so hard. I think at one point, I don't know if they ever did. They were talking about making it where you weren't allowed to sell gas cars.
Yeah, I think that's still their goal by 2030. Trump may
Yeah.
have gotten rid of that.
Yeah, I wasn't sure how it ended up. I know they were working on not selling gas cars
Yeah.
anymore, or not selling new ones.
Yeah,
You
it's
couldn't
all
bring new ones out.
it's all going that direction anyway, and like the infrastructure for EVs is starting to get ridiculous. Where like you can go to a supercharger and fill up your EV in about 15 minutes.
Yeah.
So like it's all at a mall or Buc-ee's or anything else like that.
First came out, I was like, absolutely not. 'Cause there's only like 10 places.
Right.
The
You
charge
can't
and it takes an hour and a half.
Yeah, I'm not sitting somewhere for an hour and a half to charge. Like, that's crazy. I don't have time for that.
Yeah, but no, I'd say it's gotten ridiculously awesome.
So
For
the superchargers at the gas station do like between 15 and 30 minutes, I think is what most people are saying.
Yeah.
What's the house charger look like? Is
So-
it gonna be multiple hours?
yeah, it'll be depending on what size charging you get. The fastest you're gonna get is about 44 miles per hour.
Okay.
Most like batteries have a range of about 280 to 300,
Okay.
315 miles.
So
It's gonna take a few
completely
hours, but it'll charge overnight.
on your level of charging.
Yeah.
So
You don't ever want to do level 1
level
unless you drive like 2 miles a day.
level 1 is this mobile charger.
Generally, you're gonna get 4 miles per hour.
This mobile charger that typically comes with your EV car, and so people say, oh, well, I've got a charger with my car, this is great. You plug it into a standard 120 outlet, and it gives you 2 to 5 miles of range per
Depending
hour.
on the efficiency of the battery and all sorts of stuff. So like, it is
Assuming you don't have anything else plugged into that circuit, assuming da 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 da.
So in 100 hours, you'll fully charge your battery.
Does it make sense to plug into the 240?
Yeah. So they have a 240 plug as well, but you have to have that circuit GFCI protected per code, and then you also need the receptacle EV rated. And so if you don't have those, then it's not going to charge, and like you're not protected, and that 1450 is going to burn up in about 2 years.
So most old homes wouldn't be EV rated anyway.
So if
No.
you were gonna do this,
Yeah.
how much would it charge to like come out and say, hey, I want this set up so that it would run for that? Does that make sense? I don't know if I use the right terms.
So how much would we charge?
Yeah.
So when
You give them a certain plug, right?
when we
Rated
So
plug.
that one's actually just hardwired. So
Okay.
that becomes the appliance. So we just hardwire directly to that. Then you can get up to 60 amps of charging versus the like NEMA 1450, which is the plug. You can only get about 40 amps of charging.
Okay.
So you get faster charging for the same price. So actually, most of the time, the wall connector is cheaper even if I provide it, which is what's really fun.
And then the big boys will charge you fast.
Yeah, but you have to pay for those.
And
A lot of the times they'll also have like peak hours, they increase it, or there's congestion, they'll increase it, so. If,
Is there a way to get level 3 at your house or not?
I mean, technically, yes, but I don't know very many people with like $90,000 per home. So technically, yes, but what we have to do is take it from single phase and then do a 3-phase converter to a transformer to get it to 480 volts. And then we would have to go to a rectifier to take it from AC to DC, so you can't have all three. So, yeah, you could, but
But it's a lot of
it'd be several $100,000, I guess.
And
For no real advantage, because there's no reason you need to plug in and charge for 15 minutes at your house. I don't know.
what the level 3 charger does is it takes like the pressure from a fire hydrant and shoots it at the car.
Yeah.
And so that's why it can go real fast, but you don't wanna do that every day.
It's actually bad for the battery because it creates so much heat as it's running through there. So it's really good for like road trips just to have it quick, if you don't wanna do that every single day, or even every week, because it will decrease the lifespan of the battery by a lot. So. Yeah, I'd say it's not worth it. Like I said, I don't know very many people who would want to spend that kind of money on that. If you know them, tell them to call. But, like I'm happy to do it, it's just, they're gonna replace the battery in like 2 years. Because it's gonna burn up all the wiring for me.
How much is the most expensive part of the car, isn't it? The
Yeah.
battery?
Yeah, the batteries will be about $20,000.
So would you just like, it would
I know
be
it was your
the engine in the car, I think.
Yeah, because you also have to pay the disposal fees on the battery, and it's not like they can just take that lithium-ion battery and throw it in the dumpster.
Yeah.
There's very specific ways that they have to dispose of that. Because if it gets wet at all, it starts to like So, yeah, that's where like all of the hoverboards from like 2018 or whatever, they were all catching on fire because there's a little amount of battery, so they didn't encase it properly, so it get wet, and then.
What if people cutting off the cords and setting them for the copper?
Yeah, if there's some chargers.
Yeah.
Yeah, I think people do that, which personally, like, you're an idiot. I would not cut a live cord.
Yeah, people were
Oh.
cutting with the.
Oh, I was like, yeah, I see
Yeah,
that.
400 volts of DC at a stupid average, that's very high.
I don't know, question. What's the difference in your industry from AC to DC?
AC to DC, so it's the efficiency that it runs at. So AC is what we power all of our systems on. DC is what powers your car, what powers your computer, all of your sensitive electronics. The reason we use AC is because we can transform it up, transform it down. So basically, we can take it to where the power station is out in Bastrop, and you can get 120 volts here, because they start at like 120,000 volts at 1 amp, and they come in here, and now you have 100 amps at 120 amps. You can transform it up, but DC, you can't. DC is one solid thing.
It looked like it was like a sideways.
Yeah, so AC goes in a sine wave, DC doesn't, so it's always positive, whereas AC bounces between positive and negative, and then we basically just catch the middle of it. So the peak is 170 and the valley is 170. DC is always positive, so it just runs constantly at 12 volts, or 24 volts, or whatever you have that. The problem with DC is the voltage drop on it is extreme, so running from that panel to like the front office, you would lose voltage. Which gets really bad for your sensitive electronics.
Why don't we,
And
next time we'll do like a whole AC/DC.
and then DC, we would also need to have like big generators in every single room. Like you would power this room with a generator probably the size of like a desk. So you can power this room. And then that room would also get one, and the next room would. And if we wanted to power the city with that, we either need cables the size of this table, or you'd have to put individual generators in every room. Whereas AC solves that. So it's a lot better system. You can thank Nikolai Tesla for AC voltage. He is the father of electricity, regardless of what your history book said in grade school. Thomas Edison invented the light bulb and had better marketing. He was not the biggest hydraulist. Like he invented DC, sort of, but everything that we use from Nikolai Tesla still powers our lights, the transformers that we use. He invented those. I think it was like 1918, 1920s.